This is the 13.3 homework circular approach. And the terminal side, what we have here is we have a theta's terminal side passed through the given points. Find the requested trig ratios using the circular approach. To do the circular approach, you have to know some things, like I want cosecant. And the cosecant of an angle is simply the radius divided by y, and cotangent of an angle is x over y. They're just formulas. That's all they are. Sorry, and so I need the r. R squared is x squared plus y squared. It's just Pythagorean theorem. So r squared would be 5 squared plus a negative root of 11 that is squared. It's going to give me 25 plus 11, which is 36. Remember, r squared is equal to this. So r is 6. So I'm in a good position to do things. If I want the cosecant ratio, there's my y value. The radius is 6. So the cosecant of theta is going to be 6 over negative root of 11. You clean that up by multiplying top and bottom by negative root of 11. Not negative, sorry, just root of 11. And the negative symbol gets moved to the numerator. Negative 6 roots of 11 over 11. Cotangent is simply x over y, so it's going to be 5 over negative root of 11. We're going to multiply top and bottom by root 11 over root 11, as I've done so many times with y'all. Negative symbols get moved up top. Negative 5 root of 11 over 11. And I'm not going to do a lot of these because I'm going to do all the ACT stuff, and that's going to suck up some of my time. Let's see, alpha's terminal side passes through the given points. Use a triangular approach and reference angles to evaluate the given trig ratios. So I want the triangular approach here. This is going to go left and up. And all schools tortured children comes into play. I'm finding secant and tangent, and I'm in quadrant 2 because I'm going left and up. So my answers will be negative. Anyways, I go left 3 and I go up something. So the angle starts here. It rotates the terminal side. And again, I can't right triangle that out. But I can imagine a right triangle being there. And this will be my reference angle, theta prime. Now I went left 3 and I went up root 6. I do a little Pythagorean theorem to get the missing length. A squared plus b squared is c squared. This is going to be 9 plus 6, which is 15. I take the square root. So root 15 is my hypotenuse. I want the secant ratio. I understand SOHCAHTOA. I hope you do. Secant ratio is a funny guy. Hypotenuse over adjacent. Negative symbols belong in the numerator, not the denominator. And the tangent ratio, which is simply opposite over adjacent. Opposite of theta is a root 6. And adjacent is a 3. Negative symbol belongs up top. So that's pretty simple. Number 9, angle F's terminal side intersects with a circle, radius 4 at negative 3, negative root 7. Evaluate the sine, cosine, and tangent of F, and after evaluating these ratios, use the arc sine, the arc cosine, the arc tangent to determine F's true measure. So it does help to draw these things. So radius of 4 is my circle, and I go left and down, and the angle that we're finding is not going to be given to us by a calculator. Calculator is going to help us out some. The calculator is not going to return this massive angle that we have there. I wish my pen would draw for me. It's annoying. There we go. Angle rotates to there. This is the angle. The calculator will not return that. But anyways, the radius was 4. To imagine this triangle being drawn, I went left 3 and I went down √7. So the sine of angle F using the reference angle F prime is going to be negative √7/4. The cosine of angle F, adjacent over hypotenuse, is negative 3/4. And the tangent of F is opposite over adjacent. Negative √7/negative √3. Negative over negative is positive. Now, we're going to push buttons in a calculator. The measure of angle F is going to be the arc sine of this thing. And all three of these things, at least one of these is going to be different than the other. Probably the cosine one's going to be different than sine or tangent, because cosine works in quadrants 1 and 2. Sine and tangent work in quadrants 1 and 4. So the arc sine of negative √7/4, let's see what the calculator says that is. Second sine, I'm in degree mode. I haven't changed this thing in days. It says it's about negative 41.41 degrees. That would be over here in quadrant 4, wouldn't it? It's funny how that works. All right, the arc cosine of negative 3/4 is 138.59 degrees. This is weird. Why are they different, right? Because you guys wouldn't have any idea why they're different. Then we have the arc tangent of √7/3. That's going to be a positive angle in quadrant 1, 41.41. Which one is it? Which one is it? The reason these answers are the way they are, some of it has to deal with all strippers taking cash, and some of it has to do with how things are defined. Arc sine only works in quadrants 1 and 2. That's where it returns answers. So it returned an answer in quadrant 2. Arc cosine returns, 4, not 2, only works in quadrants 1 and 2. So it returned an angle that lies in quadrant 2. Arc tangent works a lot like arc sine. It's a 1 and 4 quadrant idea, so it returned an angle in quadrant 1. The reason it did that is because positivity. All right. The reason arc sine returned an answer in quadrant 4 is because of negativity. The y value is negative here. And when we did arc cosine, we had a negative value. X is negative in quadrant 2. So which one is it? It's none of these. However, if you think about these angles that it's returning here, like these two right here, and then maybe this reference angle, you have to use your brain. Use your brain and realize there's a reference angle. This reference angle right here is 41.41 degrees. It was 41.41 here. If you did 180 minus 138.59, you get 40.41 there, or 51, whatever it is. And that's what it is. So the actual angle theta is 180 degrees plus 41.41, which is 221.41 degrees, which makes sense. The angle's in quadrant 3. It's bigger than 180. And there's that one. All right, we have all the ACT style stuff. If the cosine of alpha is √5/3 and the tangent of alpha is less than 0, which means negative, what is the value of sine of alpha? So all strippers take cash. This is positive. Cosine. Cosine is positive in 2 quadrants, 1 and 4. Tangent is negative in 2 quadrants, this one and this one. my angle lies in quadrant 4. So it's quadrant 4 that I imagine I have a triangle. And the cosine ratio is adjacent over hypotenuse. And I want the sine one. By the way, sine is negative in this quadrant. So gone, gone. So all I got to do is a little Pythagorean theorem and I get the missing length. So a squared, or sorry, root 5 squared plus a squared is my c squared, 3 squared. 5 plus a squared is 9. A squared is 4. A is 2. And direction, that's falling. And I do the sine ratio, opposite over hypotenuse. Almost put the wrong one there. Choice 3. 17 is a gimme problem. What is the sine of A? I mean, all you got to do is focus on A and go opposite hypotenuse. 7/9. Pretty simple one. Which of the following expressions is equal to the sine of 60 cosine of 30 plus cosine of 60 sine of 30? You're supposed to, this is a senior test, and the vast majority of seniors in this country take a trig class. So they're supposed to know this little idea that the sine of x plus y is the sine of x cosine of y plus the cosine of x sine of y. It's going to be choice J. Now that being said, what you can do is you can push buttons. This is a problem that's in degree mode. Check your mode, make sure you're in degree. And let's just type in the original function here. She was sine 60. Notice what I'm doing? I'm typing this in. Cosine 30. Even a kid who doesn't know anything about trigonometry can do this by hand. In fact, I'm going to do it entirely by hand. Sorry, they can do it by pushing buttons in a calculator. And then we can do sine of 60 plus 30, and we'll see if we match. Because, you know, I could be wrong this morning. So, hey, they match. It's just a simple push button in a calculator. Here's something else you can do if you're really feeling up to it. You can draw yourself a 30, 60, 90. 1, 2, 3. And the sine of 60, if you're at 60, is going to be root 3 over 2. Cosine of 30 is going to be root 3 over 2. And it says plus cosine of 60, which is a half, sine of 30, which is a half. So this will be 3 over 4. Root 3 times root 3 is 3. 2 times 2 is 4. 1 times 1 is 1. 2 times 2 is 4. And I get 4 quarters, which is 1. Now notice it talks about the sine of 60 plus 30. The sine of 60 plus 30, like that, is the sine of 90. So you're here. The sine of 90, again, it's opposite over hypotenuse, but the opposite side is the hypotenuse. So it's hypotenuse over hypotenuse. It's 2 over 2, and it's 1. Whew. Lots of ways of doing these things. There's 3 ways to do the same problem. The cosine function is shown in the standard xy coordinate plane below. One of the following equations, which one of the following equations represent this function? Which one? All right, so this will be kind of rough for a lot of y'all. Looks like they're indexing by pi over 2. That would make this pi. That would make this negative pi. 1 period, which is how long it takes for the graph to repeat, is right there. The graph is repeating. So 1 cycle or period is equal to pi. Now, if you take a trig class, you learn functions like this. Y equals A, this is actually a cosine function, so that's what I'm going to use. Cosines of bx plus, a lot of times they use omega, and then plus k. The A stands for amplitude, which I like to call my half height. B is going to affect the period. It's a horizontal compression or stretch. This is what we call phase shift. Think electricity. And this is your vertical shift. Now, none of these have K, and none of them have omega. And you also learn in a trig class what sine looks like. Sine starts low, does that, which is cool. And then you learn what cosine does. And cosine starts high. Cosine looks like that. Now, if you talk about the height of this thing, this would be your half height. That's your amplitude. 1, 2, 3. Amplitude is 3. Gone, gone. Cosine has a normal period of pi. That's what cosine has, normal period of pi. So what we do is we say that B is going to be 2 pi over the observed cycle, which is pi. B is 2 pi over pi, which is 2, which is choice K. You like what you see? Take pre-calc. If you don't, don't. 59. If the figure below shows a flying kite, at a certain moment, the kite string forms an angle of elevation of 75 degrees from point A on the ground. At the same moment, the angle of elevation of the kite at point B, 240 feet from A on level ground, is 45 degrees. What is the length in feet of the string? So the first thing that jumps into my mind is adding these two angles together. And that's going to be 120, and 180 minus 120 is 60. And the next thing that jumps into my mind is the law of sines. The sine of 60 compares to 240 as, now what do they want? They want this length right here, this string, as the sine of 45 compares to some unknown s. Now, I'm going to do this entirely by hand because I can, and I think you should too. I'm incredibly anti-technology, believe it or not. I think it robs us of who we are. I think it robs us our true purpose, which is to think and to grow. Our job is not to let others think for us, especially technology. So anywho, this talks about the sine of 60. The sine of 60 is going to be opposite over hypotenuse. It's root 3 over 2, still comparing to 240. This talks about the sine of 45. If I'm at a 45-degree angle, it's 1 over root 2, which is going to be root 2 over 2. So root 2 over 2, and it's divided by s. I'm going to do, I guess we'll just do straight up cross multiplication. 240 cut in half is 120. 120 root 2 is s root 3 over 2. I'm going to multiply both sides by 2. So back to 240 root 2 equals s root 3. Then I'm going to divide both sides by root 3. Now, I don't like the way this thing looks, so I got 240 root 2 over root 3. I'm going to multiply top and bottom by root 3 over root 3. And I'm going to get 240 roots of 6 over 3. And 240 over 3 is choice B, 80 root 6. By all means, you be a button pusher and think about how smart you are, but you're nothing. if you can't do it by hand. Anyways, there we go.